Okay, so this is the second online lecture. Uh, like continued from the previous lecture, previous online video. And this is about the estimation of returns to schooling, which was one of the leading examples in any economics, in econometrics and data analysis uh, courses. Let me start from the endogeneity problem. So in here, we are going to consider the regression context. So the general theme of this course is to estimate the effect of D, D on Y. So D is the treatment, which is schooling, education in this example, and Y is earnings in this example, which is an outcome. And we are going to consider this kind of regression. We allow additional control variables X like this. And if you look back if you read textbooks about the regression model, you should be able to find an assumption for the regression is that the D is uncorrelated with epsilon. So the education should be uncorrelated with all the unobserved characteristics to identify the effect of education. That means this is exactly same intuition as randomization of the treatment. To identify the correct result of treatment, we should randomize the assignment of the treatment. So especially in this case, like education should be randomized. So if this fails, and which is common, which is pretty common, if its failure is pretty common in economics, so we call this problem as the endogeneity problem. Endogeneity. We call D is endogenous. So you can think it as like a endogenous variable is kind of it's opposed to randomized variable. So when a variable is endogenous, it is not randomized perfectly, and it's actually the endogeneity problem is another name for selection bias, omitted variable bias, or like bad controls. So we have learned some problems in different contexts, like in causal inference or in another with another examples, but they are basically examples of endogeneity in econometrics, depending on the context and the literature. So basically, they are the same thing. So then, our solution is to use the instrumental variable, which is usually denoted as z. So the instrumental variable z should satisfy these three assumptions. First, most importantly, z should be uncorrelated with epsilon. So the main problem was coming from the correlation with epsilon. So z should be randomized. And it is randomized, and then it should affect the treatment. So you, instead of randomizing the treatment itself, but you are randomizing something else which affects the treatment. And finally, it should not affect the outcome directly. So we are randomizing another variable z, and then it has to have effects on d, and d will affect y. So instead, there should be no direct channel between z and y. Okay, so then let's go back to our example with the real data. So we would like to estimate returns to education, and y is the outcome is the log of weekly earnings, and d is the years of education. By the way, the weekly earnings, this data is from 1980 census, so it's 1980 data, and education, we are considering those who are born in the 1930s. So it's pretty kind of outdated data, but I'm just replicating the example in the textbook. So year of education, which is not binary here, because years of education can be like 12 for high school graduates, 16 for 4-year college graduates. So it is not binary. It is like 1, 2, 3, 4, 5, like discrete numerical variable. And endogeneity problem in this analysis is pretty obvious because we do not observe some ability like say intelligence or like diligence or whatever your character like personality that is pretty important in your education choice also affect your wage, right? If you are smart, then you are more likely to get like additional education, but at the same time, you are going to make more money just because you are smart, not because of your education. So, this is the typical example, the leading example of endogeneity in any economics course. So clearly the required assumption is violated. So we need instrumental variable. As I said, we are replicating Angrist and Krueger paper in 1991, and in the textbook you can find the results in figure 411 tables, 411, 412. And interestingly, they use the quarter of birth as an instrument in this analysis. Let's check if the assumptions are satisfied. First, quarter of birth affects the education decision. Education is affected by the quarter of birth, which is shown in figure 4.1.1. So, like this correlation can be found here, and the other two assumptions, like quarter birth does not have direct effect on the outcome and not correlated with the unobserved abilities. These are just assumptions. We believe, and they are plausible. So when you're earning, when you negotiate your wage, no one cares about your quarter birth, and or quarter birth, your birthday has like no correlation with your intelligence and your how smart you are. So I believe those two assumptions are obvious, pretty plausible. So we will use this as a quarter birth as an instrument. So setup is clear. Now from now, we are going to consider the main focus of this class is this lecture is on implementation of the idea. So we are going to use the two-stage least squares method. So let me review this method. Literally, it uses two stages, two regressions in two stages. In the first stage, we try to predict the treatment, the education in this context. We regress the treatment using the instrument Z and other control variables, right? So education becomes a function of your birth quarter and variable X, control variables, which I will explain later. Of course, there is unexplained error here. And what we need is, I'm going to take the first three terms, like I will ignore the error terms because the first three terms are uncorrelated with the unobserved ability, but the error term is potentially correlated with the ability. So put it this way, when you decide your education, when you choose whether to continue or not, continue to master program or PhD program or not, then your decision is based on other observed variables and how smart you are. But we don't observe that, so that is also in the error term. So we are going to remove that because that is the source of the problem. Ignore that. And in the second stage, I'm going to replace the original education, true education, with predicted education, which does not have the error term. So because this fitted value, we call this fitted value. The fitted value does not include the unobserved ability, so this will resolve the endogeneity problem, right? And so then in the second stage, we do the main regression, right? Then the coefficient of the fitted value becomes the causal effect of education on your earnings. So we are going to implement that. And as you can see, it is clear, like the just two regressions. You can use regression twice, and I will show you how to do that on Stata. So our data are from 1980, census 5% sample data, and we use men born between 1930s, and also we only use those who with positive earnings. There are some observations with zero earnings, like unemployed people. We simply deleted that. And X include age in quarters, right? So for example, if you are 40 years old, then in quarters you are like 160 quarters old, right? 160 becomes the age. And also I include age squared, as I explained in the previous lecture. Like age squared to capture the, like increasing first, and after a certain age, your wage may go down. As you get older, your productivity may decrease. So to capture this kind of hump-shaped production function, like productivity function, I include age squared. And additionally, I include year of birth dummy. So there are 10 years. So there are 10 year dummies, cohort dummies, and state of birth dummies. 50 states of birth are included. So there are simple, basic information. And I'm going to use also and the instrument. Basic idea of our analysis is to use quarter of birth, but we are going to consider 3 different ways of using the same idea. First, I will include only the first quarter dummy. So, like I will show you later, but first quarter, our main focus is the first quarter behaves a little bit different from the other quarters. So there is a education drop in the first quarter. So we will isolate first quarter, and that means we are treating the other quarters as the same group. So the first quarter versus all the other. And second method, divide the groups more finely, including all 4 quarters dummies. And finally, to divide the sample even more finer into finer groups, we could use each quarter by year dummies. So for example, those who are born in the first quarter in 1930 is one group. And and then the first quarter in 1931 is another group. We are treating each quarter as a different group. So in the end, there are 10 years, and we have 4 quarters in each year. So finally, we are using 40 dummy variables as an instrument. So as it goes down, the instrument becomes more detailed, finer groups we are using. So let's see how they work. And finally, one thing that I'd like to tell you first is that I'm going to implement the 2-stage least squares in 2 different ways. So, first method is using regress command twice, right? So that's basically why people use the 2-stage least squares. It's pretty simple to implement because it only requires regression twice. And then second method, I'm going to use the command IV regress. This is instrumental variable regress command. IV regress command is built only for IV regression model, 2-stage least squares model. I'm going to show you their coefficient estimates are the same, but the standard errors are different. So if you use regression command twice, the standard errors will be wrong. So that's what I wanted to show you in this demonstration. So let me go back, turn to Stata, and again, as I did before, I'm going to implement the same thing twice. First on the command window, and second on the two-file editor. So I explained why I'm doing that in the previous lecture. So let me set the working directory like this, and I will I loaded the data. As you can see, the data I already cleaned. So age in quarters, education, and like a log weekly wage and married, and a lot of variables. I will ignore many of them. So what I'm going to do first is I will calculate the average education by quarter. So it is possible, like I will calculate mean of education over quarter birth. So this command mean of education, comma, over quarter birth will calculate the group-wise mean. And then what you can find here is first quarter education is the lowest. I explained this pattern in class. This is a very interesting pattern, and it is pretty clear there is an increasing trend in the average education as with respect to the quarter birth. It's a pretty strange pattern. Also, you can check the similar trend if there is any trend in the earnings. If you calculate the earnings by quarter birth, also you see the same increasing trend. There is a decreasing trend here, but anyhow, the first two quarters are lower than the later two quarters. So, and then why is the earnings correlated with quarter birth? We believe that that's because of the education. Otherwise, there is no other explanation why birthday affects your income. Okay, so let me then think about let me regress the outcome with education, and we'll see what happens. I will just run this. So as you know, this regression will be biased. It has the endogeneity problem. I do not use any instrument in here. So the estimated result is about 7%. That means like 0.07. That means additional year of schooling will increase your earnings by 7%, right? But we cannot believe this result because it has endogeneity problem. So we have to use the two-stage least squares method to study it. So I will use the first. I will regress the education on the first quarter dummy first. So this is the simple first stage regression. So as I said, this is to explain education, not the income. And then what I'm going to do is, so by the way, the first quarter has a very significant effect. P-value is 0, and t-stat is pretty large to the minus side. So we are going to calculate the fitted value as so just fitted. I will define another variable fitted based on this regression, right? I will calculate the predicted fitted value for education using Q1, and then you can use this command. We have used this command when we calculate the propensity score in the last video. Okay, so then this was the first regression. These two lines will do the first regression, and the second regression is to regress. So similar regression as this, but replace education with fitted. So this is the second stage regression, and this is the IV regression result. The regression result using the instrumental variable, which is different from this. So it looks like it means that if you use quarter birth instrument, the estimated returns to schooling is now 10%, which is greater than this outcome. Okay. Also, it is pretty significant. However, what I'm going to show you here is, so this is, so far I've used regression command twice, but this is not the right way. Mainly the problem is in here. The standard error is not correct. Or better way is like, let me see here. On Stata, you can use this command, and then dependent variable is income, and independent variable is simply I will include education. And you may include more variables, but among them, I will set the endogenous variable is the education, right? As I explained, this is the endogeneity problem in education, and then instrument is Q1. This is the setup, and we are using two-stage least squares method. You could use another method, but pretty much the same. And this is what you have to do. Like, let's see how it works. Excuse me. IV regress two-stage least squares. This is like I should have not included education in another selection box, right? Let's do this. So after excluding this, it should work, right? So if you look at this syntax, this command, I'm using IV regress with option two-stage least squares. And this is the dependent variable, and education is explained by Q1. This is the instrument, and this is education, right? This is the endogenous variable. And now if you compare this result, this is the same. So this result was obtained by regression command twice. But this command is using this result is obtained by using IV regression command. These are the same, but the difference is in the standard error. Standard errors are different. This is correct, this is wrong. This is wrong, this is correct. So I'm telling you, two-stage least squares is regression twice. That is right, but you should not use regression twice on program. Usually you should be able to find a built-in command or package for two-stage least squares method. So I recommend you to use a built-in command, particularly when you need standard error. Standard error requires a different formula from the simple regression, so I'm telling you. Okay, now I am going to expand the idea to include more like finely defined IV regression, IV instruments, and additional control variables. Okay, so I will try, for example, so what you can do here is, so this was my mistake. You should not include endogenous variable here, I am going to add other variables, say age. I will include, where is age? Age and age squared, and say year of birth. And also, I'm going to include quarter of birth as I dot. So do you remember I dot? I dot means each value is included as a dummy variable. So each quarter is included as a dummy, and also I dot year of birth includes each year as one dummy variable. So this will include all the year dummies. So, and I'm going to include these dummies, like so what this means is they are regions like North Central, South Central, New England, Mid Atlantic, like South Atlantic, West North, West South, like so, like that. All the regions are included, like mountain states. Excuse me. So just include those variables, and marital status. Let's include that. So I have included all the available variables as independent variables. And what you have to do is all the other variables, all the control variables must be also included in this I instrument, right? Age, all the regions, marital status, of course, quarter birth was included, age squared, like this. So same set of variables are included in here and there. Let's see. It takes a little more time, but like you can find that the effect of education is a little bit weird, like a 53%. It's crazy. I don't know what happened. So anyhow, the including more variables will change the result, right? So this is how you implement the two-stage least squares. So now let me move to the two-file editor, and I will show you another trick. So which is very useful thing. Like, let me start with, this is to replicate Angrist and Krueger 1991. So, and what I will show you here is these variables, like control variables, will almost always move those, like included, like together, right? So, and they are used, same set of variables are repeatedly used in your code. So I will define commonly used variables as a group, as a variable list. So I'm going to use local. Local is the name of that command, x1. I will say x1. Excuse me. Here there is no quotation. Then what I'm going to do is I am going to include all these variables in here. Let's say these regional dummies included. I copy them here like this. So then this command means that these variables are summarized into one code, one command, x1. I will show you how to use that. And you may define another list of variables in this way. So x2 is a list of variables that include all the variables in x1, additionally age quarter and age quarter squared, right? So you can use them as a simple command, and it's pretty much unnecessary, but let's I will define log weekly wage as y. Then for example, you may use command like this. When you use the variable list, you have to put quotation like this. Then it will automatically calculate the regression of y on these variables. And I'm going, of course, the important variable is education. So, simple regression without instruments. So if you regress the outcome on education and education with other controls, education with other controls plus age, so you may use, as you can see, you may use the variables as you want. Excuse me, I forgot to include year of birth dummy. So then these are automatically entered here, and when I just say x2, then it will automatically recognize these variables. Okay. So then additionally, I will define instrumental variables using the same command. Local z1 is q1. The first set of instrument is z1, which only includes the first quarter. And I will try another instrument which uses 4 dummies for each quarter of birth. And the third set of instrument is including all years by quarters dummy. That means now here is another advanced command. Sharp means each possible dummies are all interacted. So there are 4 categories in quarter of birth, and there are 10 categories in year of birth. Then by connecting them with this, you are including 40. You are making 40 groups, 4 by 10 categories. So this is this is defined this way. Now let's see. We can do. Let's do the IV regression model. So I'm going to use IV regress command. Now, by the way, as I said, you should not use regression command twice because the standard error is wrong. So I recommend you do this. If you use IV regress, 2-stage least squares, and y, outcome y, and don't forget the single quotation mark, and then include x1, and education equals z1 and x1. This is one possible one set of IV regression, right? I am going to change the same IV regression with additional control variable. Okay, so then there is another regression result you are going to see, and then we may change those regression without much difficulty by changing like z2 to z3, z1, z2, z3, and x1, x2. So you can easily add additional lines for different set of variables. Okay, let's see how this is done. So I will run this. Excuse me. I realize. So when you say quotation mark, so this is the quotation mark. This is the quotation next to the enter key. But you should use another quotation. So you have to start with this quotation mark. This symbol is next to number 1 on the keyboard. So it was my mistake. The syntax was like you have to use. So the first symbol is the key next to number 1, and the second symbol is key between colon, semicolon, and enter. Right? This one. Please excuse my mistakes. By the way, these kind of mistakes are pretty common when you write a code. So almost always there are errors. So it's not that bad. Easy to fix. So anyhow, this is what I do. I hope it does not have any more error. Okay. What? Invalid name. Invalid name. I don't know, that I don't understand. Here, it's my mistake again. So, yeah, I did not fix this error. Let's try again. Okay, it's okay. It works. So, in this code, we are actually doing 9 regressions. 9 regressions are just done in like less than 20 lines. So implementation is pretty simple, and this is very efficient. Like you can easily you can fix the errors, right? And also I gave you an important tip, interesting, useful tip using local command. This will define a set of variables as one name, so you can easily copy the same variables using short commands. Okay. So I have one more online lecture on the instrumental variable and local average treatment effect thing. So I'm going to post it soon. Okay. Thank you for watching, and I hope it helps. Okay. Bye.